Standard 11 Chemistry Unit 2 Structure of Atom Part 13 Electronic configuration of atom is to be continued. To write down the electronic configuration of any atom, we must follow Aufbau principle, Hund's rule and Pauli's exclusion principle. Let's see about electronic configuration of neon. Atomic number is 10, number of electrons are 10. According to Aufbau principle, electron first enter into the lowest energy level orbital. Here we must follow the order of orbitals. Here electron first enter into 1s orbital and then enters into 2s orbital. Here 2 plus 2 4 electrons, and now rest of the 6 electrons enter into 2p6 orbital. Here all the orbitals are completely filled by electrons. So in valence shell, here all the orbitals px, py and pz is completely filled by electron. So neon is stable here. Then sodium, atomic number is 11, number of electrons 11. Electron first enter into the lowest energy level orbital, so 1s2, then 2s2, then 2p6. Here 2 plus 2 4, 4 plus 6 10, and rest of the 1 electron enter into 3s orbital, and here 1 orbital. Okay, so 3s is our outermost orbital, or it is said to be as valence shell, and its electron is known as valence electron. Here 1s is completely filled by electron, 2s also, and here 2p6 also filled by 6 electron, and then 3s has only 1 electron. So this electron is said to be as unpaired electron. 1s, 2s, 2p and 3s. Okay, so here to complete its octet, it loses 1 electron here, and 1 electron is removed from the valence shell. So it is to be converted to sodium ion. Now number of electrons are 11 minus 1, that is equal to 10. Now for sodium ion, electronic configuration is 1s2, 2s2 and 2p6. Then magnesium 12, so number of electrons are 12, 1s2, 2s2, 2p6, number of electrons here 2 plus 2 4, 4 plus 6 10, and then rest of the 2 electrons enter into 3s orbital. Okay, then chlorine, here atomic number is 17, number of electrons are 17. Electrons first enter into 1s orbital, then 2s, then 2p6. Here total 10 electrons, and 3s 12, and rest of the 5 electrons. Here rest of the 5 electrons enter into 3p6 orbital. But here we have only 5 electrons, that's why we can write here. So 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 5 17 electrons. Okay. Now let's see here. 2p6 is completely filled with electrons, 3s also, and here 3p 1 2 3 4 and 5. So here chlorine atom has one unpaired electron, one unpaired electron, and valence cell, so third cell, has here 1 2 and 3 paired electron. Okay, 3 paired electrons, 1 2 and 3. Now for here argon 18, 1s2 2s2 2p6. Okay, and then after 3s2 and 3p6. Here all the orbital is completely filled by electron. It is most stable, or it is said to be as noble gas. One, 2 and 3, 4, 5 and 6. 1s, 2s, 2p, 3s and 3p orbital. Okay. Now for potassium, 19, number of electrons 19. Here we can write for number of 18 electrons, we can write here into bracket argon, and then after it enters into 4s orbital. Okay, so in outermost shell potassium has one paired, one unpaired electron. Okay, then after for calcium 20, number of electrons 20. So from 1s to 3p6, number of electrons are included 18. So we can write here argon, and then 18, and rest of the 2 electrons enter into 4s orbital. Okay, now from atomic number 21, new pattern is followed with scandium here. new pattern is followed from here, because now from 1s to 4s2 we have 20 electrons, and rest of the 1 electrons here, it either it's enter into 3d orbital or 4s, which one has higher energy or which one has lower energy. Here 4s and 3d orbital, so here 3d orbital is being lowered, being lower in energy than 4p. Therefore 4d orbital is filled first. Sorry, here 3d orbital is being lower in energy, that's why 3d orbital filled first, and then 4p orbital is filled by electrons. Okay, so electronic configuration of scandium 21, number of electrons are here 21. So we can write here from argon 18, and then electron first enter into 3s orbital and then 4s orbital. So here 18 electrons plus 20, and rest of the electron is enter into 3d orbital. Okay, so from this atom its new pattern is followed. Okay, very most important. And from scandium to copper, it is said to be as transition elements. It is said to be as transition elements. Now for titanium, its atomic number is 22. Number of electrons are equal to 22. Electronic configuration up to argon, here number of electrons are 18. Here 4s2 20 electrons, and rest of the 2 electrons enter into 3d orbitals. Okay, so its electronic configuration is argon 3d2 and 4s2. Then after vanadium 23, argon number of electrons here 18, 4s2 20, and rest of the 3 electrons enter into 3d orbital. So here 3d 1 2 3 4 parts, and here 2 electrons, and 3d and 4s. So here for 3d has 3 electrons and 4s has 2 electrons. Now let's see another concept here. Suppose it is p orbital, or here d orbital, and so suppose p orbital has maximum 6 electrons. Okay, this kind of condition here, that means here p total number of electrons are 3. It is said to be as half filled orbital. It is said to be as half filled orbital. Maximum electrons in d orbital 10 electrons, but in case here 5 electrons, and here for f orbital 14 electrons, 5, 6 and 7. So it is said to be as half filled orbital. Okay, this kind of condition. And then this kind of orbitals are completely filled by the electrons. So here, if fully filled orbital, that means here p6, d10, f14, and half filled orbital p3, d5 and f7 have extra stability, and therefore such a condition, they are more stable. Now let's see electronic configuration about chromium. Number of electrons are here 24, and its electronic configuration is argon. And then as per our rule, here number of electrons 20 and rest of the electrons are 4, but this electronic configuration is not right. Its actual electronic configuration is 3d5 and 4s1. Why? Okay, now let's see about this concept. Here 4s orbital has 2 electron and 3d has 5 electrons. Okay, 1, 2, 3 and 4. So if fully filled or half filled orbital has extra stability, or to gain extra stability, the one electron from the 4s orbital is shift to 3d orbital, and it becomes more stable, and it becomes more stable because here in this case is 3d orbital and 4s. In this case this electron is shift to 3d orbital and its electronic configuration becomes 3d5 4s1. So 3d is half filled and 4s is also half filled, and this type of condition is more stable, and that's why electronic configuration of chromium is considered as 3d5 and 4s1. This is exceptional case, is exceptional case. Now let's see another example here for copper 29. Okay, number of electrons are 29. So its electronic configuration argon here 4s2 8 18 18 plus 2 20, and rest of the 9 electrons enter into 3d orbital. Okay, but this electronic configuration is not accept. Okay, now its actual configuration is 3d 10 4s1. Why? Same case is here. Let's see about this. Suppose here in 3d orbital and is 4s orbital. Suppose here number of electrons 5 6 7 8 and 9, and here 4s orbital. So 4s orbital is completely filled, but 3d orbital is not completely filled by electrons. Or to gain more stability, electron from the from the 4s orbital is shift to the 3d orbital. Now number of electrons are here 10 electrons. Okay, and here 4s has 1. So 4s is half filled orbital and 3d is completely filled orbital, and this such kind of conditions gives more stability to copper atom, and that's why this electronic configuration is considered. Okay, so this is very most electronic configuration for chromium. Here argon 3d5 4s1 and copper 3d10 4s1. Okay, okay friends, so next time we will discuss another topic. Thank you very much.